Hello and welcome to another video with me, Alex. This time we are going to be looking at partial fractions, and if you're following along, this is going to correspond to the Edexcel module C4, and this is going to be chapter 1 of the module. This is a module that is not very big, it's quite small, and it deals with algebraic fractions, and we're going to look at three things in it. The first thing we're going to look at is, so they're all partial fractions, and it's going to be with proper fractions, these things will all start to make sense hopefully. The next thing is fractions with repeated root in denominator, in denominator, and then we're going to look at improper fractions as well. Okay, so let's have a look then, let's get cracking. The first thing that we're going to look at, as I said, is proper fractions. Now, in an algebraic fraction, proper means that the power or the degree of the numerator is greater than that of the denominator. For example, also, by the way, as to show that the techniques that we're going to use in this work for all problems, I'm going to be making the questions up. Or making the examples up as I go along. So, for example, we could have something like, let's go with, let's say 6x squared plus 3x minus 5 over x times x plus 1 times x plus 2. Okay? This would be a proper fraction because we would have a highest power of x cubed, and therefore it would have an order of 3 on the bottom, and we would have the highest power of x squared on top, order of 2, and therefore the numerator has a lower order than the denominator, and therefore it's a proper fraction. Now, partial fractions, what we do in partial fractions is we want to express something like this as three separate fractions, okay? And what that looks like is this. We say we want this to be three fractions, one where the denominator of each fraction is one of these roots here in the denominator. So we'd have a over x, add b over x plus 1, add c over x plus 2. And we want to find the values of a, b, and c that make this statement true. That's what partial fractions is all about. We want to take one massive fraction that we've got like this, which may be, for example, very difficult for us to integrate, and we want to express it as three separate fractions, each of which we could integrate quite happily. So the way that we do this is we solve this equation. Now we have this set up here. We need to find values of a, b, and c that satisfy this statement. So what we do is we rewrite this right-hand side as being one fraction. Okay, and the way that we do that is we get the denominators of all of these to be the same. So in this case, we would have a times x plus 1 times x plus 2. And now that's all over x, x plus 1, x plus 2, added to b, x, x plus 2, all over x, x plus 1, x plus 2, add c, x, x plus 1, all over x, x plus 1, x plus 2. So that is using the exact same sort of logic you would use to add together simple fractions, non-algebraic fractions. We want to make the denominators the same, And so, for example, in the case of a over x, we need to times the denominator by x plus 1, x plus 2, and so we times the numerator by x plus 1, x plus 2. This allows us to write this as a lots of x plus 1, x plus 2, add bx, x plus 2, add cx, x plus 1, all over x bracket x plus 1, x plus 2. And now we can write this statement. We've got the same numerator on the right hand side as we do on the left hand side. And so we can say, same denominator. So we can say that the numerators must be equal to each other. So we can write that 6x squared add 3x minus 5 is equal to a bracket x plus 1, x plus 2, add bx, x plus 2, add cx, x plus 1. Let me just nick this quickly. That didn't work. Just copy that and we'll move over to a new page. Okay, so this is our statement that is definitely true. Now what we do, to figure out the values of a, b and c, we need to substitute in convenient values of x. Okay, and we'll determine those convenient values by values that will make one of the fractions 0. Okay, for example, let x equal minus 1. Okay, we can sub that into our left hand side and we get that, well, 6 minus 3 minus 5 would be equal to, now if we sub minus 1 in here, this fraction here goes to 0, so this whole term is 0. Likewise, this fraction, this bracket here goes to 0, so this whole term is 0. It's only this one that gets left, and we get b times minus 1 times minus 1 add 2, which would be, this left hand side is 3 minus 5, which is minus 2. So we'd have minus 1 times 1, which is minus 1, minus b. Therefore b would be equal to 2. Okay, we pick another convenient value. This time we're going to let x equal minus 2. And we'll have that it's 6 times 4 this time, which is 24, minus 6 minus 5 will be equal to, okay, again, this term immediately becomes 0. This time this term becomes 0, and we get left with only the c term, which is c times minus 2 times minus 2, add 1. So we have 24 minus 6 is 18, minus 5 is 13. This time it's equal to minus 2 times minus 1, which is positive 2, to c. So c will equal 13 over 2. And we've got to come up with one last, let's get our equation back, one last convenient value. So this time let's say let x equal 0. We'd have that minus 5 equals, b term is gone, c term is gone, and we get a times 1 times 2. So we get that 2a equals minus 5, a equals minus 5 over 2. Now what we minus 5, shoot these values back into our original fraction equation, which would give us minus 5 over, now this is 2x on the bottom because it's minus 5 over 2, add 2 over x plus 1, add 13 over 2 lots of x plus 2. And there you have it. We have now successfully split our fraction into 3 partial fractions. that's partial fractions. That's basically what we've got. We can do this with as many roots as we like on the denominator. You just keep adding another fraction. So you'd have a, b, c, d, etc., etc. That's the first thing. The next thing that we have to be able to do is we need to be able to do this for repeated roots. Now the procedure for repeated roots is exactly the same as it is for non-repeated roots. However, there is a very slight change, and the slight change will be this. Let's look at an example. Let's look at the example of 11x squared plus 14x plus 5 over x plus 1 squared 2x plus 1. Okay, so now you can see we've got this repeated root, we've got this squared on the bottom. Okay, this is still a proper fraction at the moment because the order of the numerator is 2 and the order of the denominator would be 3, so we're still good on that front. All that happens here is you have, just as you had before, x plus 1 be 2x plus 1, but you now have an extra one, which is the x plus 1 squared. Okay, that's the only difference, and then you follow just as you did before, and you can work out what a, b, and c are, just like before. I'm not going to do it because it's exactly the same. You can try it yourselves. But the process from that point is exactly the same. The only thing we have to note is we now have this x plus 1 squared term on the bottom. Okay, perfect. So let's look at then the last thing, which is improper fractions. Now this is slightly different. Okay, so let's have an improper fraction is something where the order or the degree of the numerator is equal to or larger than the degree of the denominator. Okay, so it could be something like, let's say 3x squared minus 2x plus 4 all over x plus 1 x minus 2. Okay, let's say this. So the degree of the numerator is now 2, the degree of the denominator is also 2. Now the way that the Edexcel textbook would tell you to do this is, and I'll show you that, is you actually do this using long algebraic division. Okay, so you would start by multiplying out this bottom bracket, which would give us x squared plus x minus x minus 2. And you would then perform long algebraic division on this. Like so, which would be, I would have a 3x squared, sorry, 3 there, which would give us 3x squared minus 3x minus 6. So that would go minus 2 minus minus 3 would be x, 4 minus minus 6 would be 10. Just like so, and then this means that you can rewrite the fraction 3x squared minus 2x add 4 over x plus 1 x minus 2 as 3 add x add 10 over x squared minus x minus 2. And now you can apply partial fractions to this fraction that's left over because it's now a proper algebraic fraction. This is fine, you can do it this way and it will work. However, I think there's a slightly quicker way, which is if we take our fraction again, 3x squared, what was our fraction? 3x squared minus 2x add 4 all over x plus 1, x minus 2. I think that we can skip out the step of long algebraic division if we note something. We have a numerator, degree 2, and a denominator, degree 2. So when we do that long algebraic division, we will get, at most, a constant, and then something that we can split into two fractions. Oh, sorry, that should be a b. C over x minus 2. Okay, this will save us a lot of time, because what we can now do, which I'll show you, is we can do the same procedure that we would have done before, and we can rewrite this as a lots of x plus 1, x minus 2 over x plus 1, x minus 2, and b x minus 2, x plus 1, x minus 2, and c lots of x plus 1 all over x plus 1, x minus 2. And that means that we can write 3x squared minus 2x add 4 equals a bracket x plus 1, x minus 2, add b lots of x minus 2, add c lots of x plus 1. Okay, and what we can say is, again, if we let x equal, let's say 2 this time, 2 squared is 4, times 3 is 12, minus 4, add 4, equals this one goes, this one's left. So you get 2 add 1 is 3, 3c. C would equal 4. We can let x equal minus 1. We get 3, add 2, add 4, equals this one goes, and we're left with the b term. Minus 1 minus 2 is minus 3, minus 3b. 3 add 2 is 5, 5 add 4 is 9. Divided by minus 3b equals minus 3. And then all we have to do for the last one is put in any value of x that we want. So, again, let me just take this quickly. And put it over here. So we can simply say let x equals 0, easy value, and we get 4 equals 1 minus 2a minus 2b add c, and so 4 would equal minus 2a, and then b was equal to minus 3 times minus 2 is plus 6, c was equal to 4, add 4, and you get that minus 2a equals minus 6, so a equals 3, just as it did before, and we can say that 3x squared minus 2x add 4 over x plus 1, x minus 2 is equal to 3 minus 3 over x plus 1 add 4 over x minus 2. Just like that. And this will work for any powers. All you have to do is know what the maximum case that the algebraic division would result in. For example, if you've got something to the power of 4 over something squared, doesn't matter what it is, plus dot dot dot, plus dot dot dot, you'll end up with something squared, okay? It's the difference in the degree of the numerator and the denominator. So your bit out the front would look something like ax squared plus bx plus c, because you'd end up with a quadratic. Okay, and then you can add on whatever it is, d over e over dot dot dot. So it works at any powers. It depends on the question whether it is simpler to use long algebraic division than it is, or whether it is to use this method. I found that if there was a difference of 1 between them, or if it was the same degree, then it was quicker to use this method. If it was greater than 1, then it's quicker to use algebraic. Okay, so I've shown you both so that you can see both, and you can pick and choose which one you want to use in different situations. That's the whole chapter. That's everything in this chapter, so I hope you enjoyed it, and I will we'll see you again next time. Thanks for watching.